Alright guys, so today we're going to talk about solving systems of equations again. We're just going to go over all three different types of methods. So we're going to go over graphing again, substitution, and elimination. So let's start with the graphing one. So if I look at these problems, they're not already set up in y equals. So what we have to do first is to set them up in y equals. So if I take the first equation, 2y equals negative 12x plus 22, I know that I would have to divide everything by 2 in order for this equation to be in y equals. So then it would be y equals negative 6x plus 11. So then I would come over here on my graph and graph negative 6x plus 11. So 11 would be up here, and then I would go down 6 and to the left one. Oh, I'm sorry, to the right one. Oops. And then down 6 more and to the right one. And down 6 more and to the right one. So then if we connect our dots, we have a line that looks something like this. So then we need to take our second equation and solve it for y as well. So that equation is 3x plus 2y equals negative 5. So I need to subtract 3x from both sides first to get 2y equals negative 3x minus 5, and then divide the entire equation by 2. So I get y equals negative 3/2 x minus 5/2. So 5/2 isn't something that we normally see when I'm graphing, but I know that this is the same thing as negative 2.5. So that means on my graph I'm going to start at negative 2.5, which is somewhere kind of right here. And then it says down 3 and over 2. So down 3 and over 2. Down 3 and over 2. So when I graph this one, I can see that the two lines cross right here at 3, negative 7. So that would be my solution. My solution would be 3, negative 7, because that's the point where the two lines cross. So I want you to go ahead and pause the video and try to do this practice problem on your own. Okay, so let's move on to substitution. So I know substitution is when I take one equation and put it in for something else in the other equation. So we generally have clean and messy when we do these problems. So the clean one is the equation that's already solved for y, and the messy one is an equation that's not solved for y or x. I'm sorry, clean could also be solved for x. So if I'm doing this clean and messy style, I know that I would put y equals x minus 1 over here, and then 2y equals 4x plus 4 over here. So if I know that y equals x minus 1, then I should be able to plug it in for y over here. So that would give me 2 times x minus 1 equals 4x plus 4. So when I finish solving this, I know I need to distribute, so I'd have 2x minus 2 equals 4x plus 4. And I would subtract 2x from both sides to get negative 2 equals 2x plus 4. And then subtract 4. I ran out of room. To get negative 6 equals 2x, and then divide by 2 to get x equals negative 3. So once I know x, I can plug it back into this equation over here and solve for y. So y equals negative 3 minus 1. Well, I know that negative 3 minus 1 is negative 4. So my solution would be negative 3, negative 4. So when you go over to your practice problem, you notice that one of them, neither one of these are solved for y, so you really don't have, or x, so you really don't have a clean equation. But you can easily take this top one and divide everything by 4 to make this become y equals 5x. Then that would be something really easy to plug into the second equation. So go ahead and pause the video and do the practice problem, finish the practice problem on your own. Alright, so let's look at the last one, elimination. So we know elimination is when we add two equations together in order to get either the x or the y's to be eliminated. So I know that to eliminate, I either have to have the numbers in front of the x's the same, with one of them a negative and one of them positive, and I don't have that right here. But it looks like I could easily take the top equation and multiply it by 3. By multiplying it by 3, I would have y values of negative 3y and then a bottom one of plus 3y. So if I multiply this whole equation by 3, it becomes 6x minus 3y equals 18. And the bottom one just stays the same. So from here, we would add the two equations together. So when I add 6x plus 3x, I get 9x. Negative 3y plus 3, this should be a y, sorry guys. Negative 3y plus 3y would give me 0y. And then 18 plus negative 9 would give me positive 9. So then all I have to do is divide by 9 to get x equals 1. So once I have x, all I have to do is plug it into one of the two equations, the original ones, and solve for y. So if I put it in the second one, I could say 3 times 1 plus 3y equals negative 9. So when I solve, I know that 3 times 1 is 3. And then I would need to subtract 3 from both sides. So I get 3y equals negative 12, and then divide by 3 to get y equals negative 4. So my solution would be 1, negative 4. So go ahead and look at the practice problem. So I know there's not a number that I can multiply 3 by to get it to be 5, and there's not a number I can multiply 2 by to get it to be 3. So we may actually have to multiply both equations. If I look, I know that this one's a positive and this one's a negative, so maybe I can multiply these by something each to get the same number. So like if I multiply the top equation by 3, I would have 9x plus 6y equals negative 27. So if I wanted this middle number right here, this negative 3y, to be negative 6y, what would I need to multiply it by? 2. So I take this whole equation and multiply it times 2. So go ahead and add these two equations together and solve for x, and then go back and solve for y.